Today we're looking at creating line plots. And when we're doing this, we have our blank number line set up. And the thing to remember is that a line plot is graphed on a number line. So it's evenly spaced out through a pattern. The first thing I need to do is find the smallest and largest number. So I can see that 2 is my smallest and 16 is my largest. So I just need to make sure that I start with 2 and end with 16. It can go smaller than 2 and larger than 16, but those have to be in there. Next we're looking at what we can count by. All of my numbers here are whole numbers, so I can simply count by ones. So if I start on my first marking of 2, I just want to make sure there's enough space to fit. Otherwise I might have to count by 2s, 3s, 4s, or 5s. So if this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I can see that there's plenty of space to fit. So I'm actually going to start a little bit lower than 2. I'm going to start with 0 and number each hash according to my pattern of ones because I know that they all will fit. And I can see that I've reached 16, so I know that all of my data will fit. So as I'm numbering my line plot down here, I was just focused on the smallest and largest number. The data up here means absolutely nothing when I line my number line, because I am just sequentially ordering by ones in this case. So now our next step is to plot the data. I have a 3, so that's 1x, 7, my lowest of 2, 8, 10, and I have a second 8, my x goes on top, second 3. So remember, every number on the number line here may not be represented. All you're doing is putting an X for every number that you have. And now I have my line plot created. The last step is we need to have a title and we need to identify what these numbers represent, but this data has no meaning right now. We are just practicing creating the line plots. Here we have another set of data. And again, my first job is to find the smallest and the largest number. So I can see that I have 4 and 18, and I need to see what I'm going to be counting by. And here I can see that I have halves. So counting by ones is going to make it difficult to plot all of my data. So I'm going to see if I can count by halves and fit the data. 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5. So I'm not reaching my highest number of 18. So I have two choices. I can add a few spaces to my line plot to fit, or I can also modify my line plot in a different way. I can add half markings between to signify my halves. And now I know that's going to give me enough space to easily go from 4 to 18. So I'm actually going to start at 2 and go until I fill the number line. And so now each of these markings shows a half. I just have to be sure that I can write very neatly to fit in this tight space. So I start at 2, 3, and I'm going to count all the way up, knowing that the markings in between represent our halves. So you should be doing the same on your line plot. So now we're ready to plot our data. 6.5 is going in the middle. 8. I'm actually going to fix my 6.5. I had it sitting a little bit too low. I need it to be just as high as the whole numbers. 18, 13.5, 4, 7.5, 6. Again, this is why it's so important to be able to write neat, small X's so that you're fitting them all. Whoops. It's at 9.5. 10, 12, and 13.5. So you can see that it's a little bit tight to fit some of our markings, but as long as we write neatly and we count by a sequential pattern, we've created a line plot. Our last two steps would be our title and what the numbers represent. Again, we're just practicing the line plot for now.